So an important question that we always need to ask ourselves whenever we're building a model is that how do we know that a model is right? So in order to answer that question, we need to perform model verification. So one of the most common verification techniques is to compare our simulation results with an analytical model that we know is right. So what I've done here is that I have performed queuing analysis, and I'm not going to go over the details of it because we will have a whole lab on queuing models. But let's just assume that we know that this analytical model gives us steady state estimations of the performance of our system. So I know that at steady state, I expect to see an average 5 people in the system, and utilization is going to be around 0.83. So when I compare these values, I will see that my average number in system and average time in system in my simulation results are much lower than what I see here. So this can be an indication of a problem here. So either my model is wrong, or my expectation is wrong, or it could be because of randomness. So that means I haven't run enough replications. Now in this case, I have run 200 replications, which seems like a fairly large number. And I know that I haven't made any mistakes when I was developing this simulation model, and I trust the calculations I've performed here. So uh, So what could be the problem here? It turns out that the problem is that uh, my simulation model does not really correspond to this analytical model because this analytical model gives me steady state performance. That means I need to run my model long enough to get to the steady state. Secondly, um, the assumption of the queuing analysis is that everything is exponentially distributed. So one thing that I need to do the first thing that I need to do is to change the distribution of my processing time to exponential with the same mean value. And also, I need to go to my experiment properties and run my model for a longer time. So this time I'm going to run my model for 50 hours, and I'm going to reset and run the model. And the run is finished, and now I can go ahead and compare my values again, and this time I see that my values get much closer to my expectations, but still I'm getting 4.76 instead of 5 for number and system, and 0.23 instead of 0.25 for my time and system. So there seems to be a bias that makes these two values smaller than their expectation, and that's really because we start the model um, in an empty state. So when we run the model, the first few entities uh, really don't spend any time in the queue because we start with an empty system. So we have this initial bias that we call initial transient, and we'll go over this concept later on. However, there is a solution to get rid of this initial bias, and that is basically by using something we called warm-up period. So if I go to my experiment properties, I can see that one of the properties is the warm-up period. So I can add a warm-up period here. So I'm going to add 25 hours of warm-up period. And what it does is that when I run my experiment, what Simio does is it runs each replication for 50 hours, but it throws away the results of or the statistics that it collects during the first 25 hours of each run in order to hopefully get rid of this initial transient bias. So now when I look at my values, they got closer to my steady state results. And if you want to get even closer to these expectations, you can go ahead and run your model for a longer time and increase your warm-up period. Um, and hopefully you'll see that your results or values get closer to your expectations. Um, but now I can tell that I'm confident that my model is right because all my expected values fall within the confidence interval if you consider the half-bridge. And so now I can claim that my model is verified. Now I can go back to my model and basically change my uh, exponential distribution for processing time back to what it should be, which is a triangular distribution um, with a minimum value of 1, a mode of 2.5, and a max of 4. And now, since the only modification that I made after I verified my model was changing the processing time back to its original value, now I can still be certain that my model is still verified since, or at least as long as I don't make any mistakes in putting the parameters of my triangular distribution in my model. So I can go back and basically, go back to my run and change my run length to 12 hours again and go to, or let me basically create a new experiment here. So my second experiment will be based on 200 replications. So now I can run my model and report um, the number in system and the average and maximum time in system and the scheduled utilization for this system, um, which was required uh, by the problem statement. So now I would like to go back to the model and improve the animation features of the model a little bit. So we're going to do it in two ways. So the first thing I'm going to do is I'm going to select my customer entity, and I would like to change the symbol of my customer entity. I can use Simio's built-in symbols. So for the first symbol that I would like to use, I'm going to select a female symbol. And then when I run my model, and you can simply press 3 to go to the 3D mode and run your model, you will see that my customers now walk on the path, and instead of just having a triangular shape, I have a different symbol that makes my model look more realistic. Uh, but what I really want is that I would like to have multiple symbols for my customers so that when I run the model, you will see different people in different shapes and clothes. So here is what I'm going to do. So I'm going to add an additional symbol to my uh, model entity. So I'm going to select the new symbol that I just added, and I'm going to select a different symbol now. So let's say another female symbol. And now I want another one. So I'm going to select the third one. And this time um, I'm going to select a male. And the fourth one. And I'm going to select a another male. So now when I run my model, I can go to 3D mode, and I still see that all of my entities are of the same type, the first symbol that I just defined. So there's one more thing that I need to do. So I just click on my model entity, and its properties appear in the right, and I can go to its properties under animation class. You will see that there is a random symbol property that is set to false. So if I just set that to true value and rerun my model, you will see that the entities that are created um, uh, use different symbols that I just defined. So you can define as many symbols as you want to add more diversity to your customers. The other thing that I would like to show you is changing the symbol, but of the server. But this time I would like to import the symbol or download it from Google 3D Warehouse. So I'm gonna go to download symbol, and when I click on it, this window will appear. That takes you to Google 3D Warehouse, so you can search for whatever symbol you want. So what I want is a hot dog stand. Search, and you can select any of these 3D models. I'm going to select just one of them randomly. So this one you can look at it also in the 3D view. I'm going to download this, and when you download it, you can basically set the orientation. So I'm just going to rotate it. So now this side is forward, that's the back of it. Say OK, and now I changed my or the symbol of my server. Alright, now I just need to change its size a little bit, maybe smaller, and then just make sure that I have 1, 2, 3, 4, 5, 6, 7, 8 meters here. Now I can run my model again, and you can also go ahead and add more animation features